Can you master the calculus topic of finite limits in 5 minutes? Test your limits in calculus. Let's go. So the first in our series of finite limit possibilities is the simplest example. That is, when you simply have a continuous function and you can just plug in the limit value. So we'll call this one plug and chug. So this is a rational function that is defined and continuous everywhere. So we can find the limit as x approaches 4 of this function by just plugging in 4 for x and evaluating, taking care to do multiplication before addition. So we end up with 17 over 7, which is 1. Congratulations, you have now attained level 1 mastery. Next, if we get a form where we're dividing by 0, or we have 0 over 0, we can't use the previous plug and chug method. In this case, we have the limit as x approaches 2 of two polynomials that both evaluate to 0. However, we see there's a fabulous thing. They can both be factored. And when we factor them, we can see that they both have a common factor of x minus 2, which can be canceled. Now we can plug and chug into the expression that remains, and we end up with 7 over 4. You have now attained level 2 mastery. We're moving up. Once again, we have an expression that does not evaluate easily to anything by plugging in the limit value. However, we have a binomial squared in the numerator, which we can multiply out, applying the reference rule, with the hopes that we'll be able to cancel the value h. After eliminating the 9s and combining like terms, we see we have a factor of h in both the numerator and denominator, which we can cancel, and then the limit is easy to find. You have now attained level 3 mastery. Let's move on. Our next method we call simplification beats vexation. In this case, we have the limit as x approaches 8 of an expression with fractions in the numerator, so we're going to eliminate them and simplify the expression to something that can be evaluated. To do this, we'll multiply the top and bottom of our fraction by the least common multiple of the denominators of the inner fractions, which are 8 and x. So the least common multiple is simply 8x. Next, we can apply the distributive law to get 8x in the numerators of our inner fractions, and then we see we can cancel and eliminate those fractions. Then finally we see there's a common factor of x minus 8 on the top and bottom of the fraction, which can be canceled, finally yielding an expression whose limit can be evaluated. You have attained level 4 mastery. Let's go forward. Our last technique for solving finite limit problems in calculus involves multiplying by the conjugate. The conjugate is formed by changing the sign between the two terms in a binomial. Hence, the conjugate of 3 minus the square root of x plus 3 is 3 plus the square root of x plus 3. Hence, we multiply both the top and bottom of the fraction by this expression. We can now write the expression as a single fraction as shown. Next, we use the reference formula for the difference of two squares to multiply the two binomials in the numerator. We can see that the numerator simplifies to 6 minus x, which fortunately will cancel with the 6 minus x in the denominator to give a simpler expression whose limit can be easily evaluated by our plug and chug method. Then finally we plug in 6, and we see that our expression evaluates to 1/6. You have now attained level 5 mastery. Let's move on. Everyone loves a bad boy. In this final section, we exhibit a couple of typical expressions where the finite limit does not exist. These uncooperative expressions typically have some feature, like oscillating between values as the variable gets close to some number, as in our first example, or dividing by 0, as in our second example. In the first example, we note that as x gets close to 0, 1 over x goes to infinity, and the cosine of 1 over x will just oscillate between 1 and minus 1. Hence, the limit doesn't exist. In the second example, as x approaches 5, the expression approaches positive infinity. Hence, once again, the limit doesn't exist. You have now attained level 6 mastery, and our journey together has ended for now. Let's move on. Please like the video and subscribe to the channel. Stay tuned for the bonus problem right after this.